Hello, hello. So let's see what we got going on over. Yeah. All right. Says here, tweak to Schrödinger's cat equation could unite Einstein's relativity and quantum mechanics. Okay. Interesting. Theoretical physicists have proposed a new solution to the Schrodinger's cat paradox, which may allow the theories of quantum mechanics and Einstein's relativity to live in a better harmony. The bizarre laws of quantum physics postulate that physical objects can exist in a combination of multiple states, like being in two places at once or possessing various velocities simultaneously. According to this theory, a system remains in such a superposition uh, until it interacts with a measuring device. So you're saying you measured something, and that is somehow proof that before you measured it, it was different? But part of this is science. Such an abrupt change in state of the system is called a collapse. Why would it collapse simply because you measured it? Physicist Erwin Schrödinger summarized this theory in 1935 with his famous feline paradox, using the metaphor of a cat in a sealed box being simultaneously dead and alive until the box is opened, thus collapsing the cat's state and revealing its fate. No, that simply illustrates that given the lack of knowledge of a certain thing, anything can be true about anything that is possible can be true uh, without evidence to the contrary. So if you believe something happened, or you believe in God, or you don't believe in God, like both can be true as long as there's no evidence showing that one person is wrong over the other. It, it, it's not a literal thing where the cat is both alive and not at the same time, because given enough time in the goddamn box, the cat is guaranteed not alive. Like, what do you? The cat's been in the box 10 days. No one gave him any food. It could be alive or it could be not be alive. Like, no, it's done. It's over for the cat. However, applying these rules to real world scenarios faces challenges, and that's where the true paradox arises. It's a paradox of perception, not a paradox of reality. While quantum laws hold true for the realm of elementary particles, larger objects behave in accordance with the classical physics as predicted by Einstein's theory of general relativity, and are never observed in a superposition of states. Okay. Superposition. Okay. Describing the entire universe using quantum particle principles poses even greater hurdles as the cosmos appears entirely classical and lacks any external observer to serve as a measuring device for its state. So you're saying because the outer universe is not being observed at the moment, it could be anything, could be in any state all at the same time. The question is, can the universe, which does not have a surrounding environment, being such a superposition? Lead author Matteo Carlesso, a theoretical physicist. Okay, so theoretical physics is kind of dumb. They might as well be theological scholars, because what's the difference between that and freaking, religion? You just you're making stuff up at this point. Like what evidence do you have to show that your theory is in any way close to the truth? Because you're saying an object before being measured is in multiple states, but yet you can't prove that they were in multiple states based on anything. How about we don't observe the object so it doesn't lose its magical powers, and we observe its effect on its surrounding? But then it would be measured, right? So now you would have no way to prove that your nonsense is nonsense. Observations say no. Everything goes along the classical predictions of general relativity. Then, what is breaking such a superposition? To tackle this question, Carlesso and his colleagues proposed modifications to the Schrödinger equation, which governs how all states, including those in superposition, evolve over time. Specific modifications of the Schrödinger equation can solve the problem. What problem, sir? Carlesso said. In particular, the team added terms to the equation that capture how the system interacts with itself. How? How do you change a system to better capture how a made-up thing interacts with itself? As well as adding some other specific terms. This in turn leads to superposition breaking down. I think that theoretical physicists are such a pointless vocation that they have to make themselves relevant by making shit up. That's what I think. I think they're professional bullshitters. And in the absence of anything relevant, they just start making stuff up and they're like, well, we fixed the problem. Such effects are stronger the larger the system. How do you know this? Because according to you, if it's measured, it's no longer valid. Crucially, these modifications have little impact on microscopic quantum systems, such as atoms and molecules, but allow larger systems like the universe itself to collapse at frequent intervals. We can't observe it, but trust me, I changed the numbers and the universe constantly collapsing and stuff. You know how the universe goes. Giving them definite values that fit with an observation of the cosmos. Bruh, that was like the biggest load of bullshit I've ever heard in my life. The team described their modified Schrödinger equation in February in journal. Okay. In their tweaked version of quantum physics, the researchers eliminated the distinction between objects subject to measurement and measuring devices. Okay, so there was a distinction between objects that's subject to measurement and the measuring device. Okay, I think that's an important distinction because some objects interact in the world that in a way that makes measurement a little bit easier absent a device, and some objects they're just inert and you need to use a device in order to measure them. So I'm not sure why eliminating the distinction would help unless the information contradict each other, and saying that measuring it alters its state somehow contradicts with the fact that some states are obvious from simple observation without absence of measuring device. So you eliminate the distinction and your nonsense seems more plausible. Instead, they propose that each system state undergoes spontaneous collapse at regular intervals, leading to the acquisition of definite values for some of their attributes. Well, that sounds chaotic. So let's just measure everything so that it just chooses a state, apparently. For large systems, spontaneous collapse occurs frequently, rendering them classical in appearance. Subatomic objects interacting with these systems become part of them, leading to rapid collapse of their state and the acquisition of definite coordinates akin to measurements. With no action from external entities, any system localizes or collapses spontaneously in a particular state in place of having a cat being alive or not. One finds it alive or not. This man should not be labeled a goddamn scientist or physicist or whatever. The new model may explain why our universe's space-time geometry doesn't exist in a superposition of states and obeys the classical equation of Einstein's relativity. Why? Why is that? Because it could be measured. Because it could be measured and it disproves your theory. So then you had to change and eliminate the distinction in order to make it work. Our model describes a quantum universe which eventually collapsed, thus becoming effectually classical. Or Lesso said, we showed that spontaneous collapse models can explain the emergence of a classical universe from a quantum superposition of universes, where each of these universes have a different space-time geometry. So not only can their state of being in multiple states at once be changed through measurement, it can also be changed through them just randomly collapsing into that state. Gotcha. While this theory may explain why the universe seems to be governed by classical laws of physics, it doesn't make new predictions about large-scale physical processes. Listen, man, there's a reason I'm an atheist, and it's because it just sounds like a lot of made-up bullshit. And I would say that this applies. This is the exact reason why I'm an atheist. And these people right here with this nonsense are getting on my goddamn nerves. This is dumb. However, it does make predictions about how I'm so done. So done. Anyways, until next time.